In this part of the video, I will discuss the displacement time graph. In the displacement time graph, the time is taken on x-axis and the displacement of the body is taken on y-axis. From this graph, we can determine the velocity of the body. Since velocity is a ratio of displacement and time, therefore the slope of displacement time graph gives the velocity. If the slope is positive, it implies that the body is moving away from the starting point, but if the slope is negative, the body is returning towards the starting point. Now we will consider some cases in the velocity displacement time graph. Case 1. Case 1 means if the position of a body does not change with time, the body is said to be stationary and displacement as measured from the origin at all instant is same. That is t equals to 0. So the displacement time graph is a straight line. You can see displacement time graph will be a straight line parallel to the time axis. Here x-axis I have taken that as time and y-axis as displacement. So if the body is not moving, there will be no displacement. So the line will be parallel to the x-axis. It will be a straight line parallel to the time axis as shown in the figure. In this figure, OP is the distance of the body from the origin and it remains same at each instant. This OP is a distance, okay, and it will not change. Next one, case 2. In case 2, if a body is moving with uniform velocity, its displacement increases by the same amount in each second, and so the displacement time graph is a straight line inclined to the time axis. The velocity of the body can be obtained by finding the slope of the straight line. So we can see over here x-axis and y-axis. If the body is moving with a uniform velocity, we will get a straight line passing through the origin. Okay, as the time will increase, the displacement will go like that. We will get a straight line passing through the origin. Example, you can take a car is moving on a straight path in a given direction with a uniform speed. Okay, so we can say for a body moving with uniform velocity, the displacement is directly proportional to the time. Here the displacement is directly proportional to the time. Next, case 3. Case 3 we can take like that. If a body moves with varying speed, that means the body is moving with non-uniform speed, variable speed in a fixed direction, that is a variable velocity. The displacement time graph is not a straight line, but it is a curve. The velocity at any instant can be obtained by finding the slope of the tangent drawn on the curve at the instant of time. So we can see this one here. We have put this this is a time and this is a displacement, and you can see this is the curve we are getting. Is a velocity time graph. We are getting a curve in case of a variable speed. So this is a displacement time graph with a variable velocity. So slope we can take as BC by CT. So by this slope we can determine the velocity. So what will be the conclusions? Like that, if the displacement time graph of an object is a straight line parallel to the time axis, the object is stationary. If the graph is straight lined inclined to the time axis, the motion is with uniform velocity, and if the graph is a curve, the motion is with variable velocity. So these conclusions we can take out from this graph. Now in the displacement time graph, the slope of the straight line or the tangent to the curve of an instant gives the velocity of the object at that instant. If the slope is positive, it represents the motion away from the origin, and if the slope is negative, it represents the motion towards the origin. Knowing the velocity of the object at different instants from the displacement time graph, the velocity time graph can be drawn.